should know what's pollination. It's an ecosystem of tools for environmental building design and simulation. The goal is to get you from a question to actionable data quickly. And that's how we think about it, not this. This is what people really think should happen. This is what really happens. You have initial question. You get initial data that informs you to ask the informed, better question, and you get some actionable data. And this goes over and over during the process of your studies. And then this is a famous graph that we have that shows how pollination helps, starting from how we work these days together and what is the problem with collaboration. Again, I'm not going to go all the details and bore you. The problem is that it takes about 2 weeks on average from the time that you submit a model to a consultant to give you the results. And during this time, the design changes. And as a result, when you get the result, you're getting the result for some other design that doesn't exist anymore. And a major part of the challenge is what we write here, cleaning up the model, but really the consultants here, and we had a presentation last week, was great that everyone who presented, they really redraw the model. Like cleaning up a model is kind of like what we want to do, but usually just like people decide, let's just redo everything. And hopefully this presentation changed your mind that between 100% redrawing and like full automation, there is a lot that can be done. And that's the area that we are really interested in. And of course, like simulation sometimes can take a long time, and that's why we have cloud computing. So the way Pollination helps with this is it stands in the middle. It allows you to share your solution as recipes, and then people access the recipes instead of sending you the model. So it's a more smooth collaboration and extra time and all good stuff, and you can take vacation and all that you already know. So to do that, we have developed 4 different technologies. Actually, today I'm going to tell you the 5th one, which is built on top of recipes and web interface and cloud computing, and actually connects to CAD. So with these 4, we have CAD plugins, recipes, cloud computing, and web interface. Pollination is a hybrid solution. It's not cloud only, it's cloud first, but you can run everything locally. It's built on top of HB.json and recipes that we have written. They're all standardized, they all have validation, and they're all open source, the parts in the middle here. So you can develop your own. You can run simulations locally. You can run simulation on the cloud. You can visualize the result locally. You can visualize results on the web. So kind of like integrated, having different ways to go. And as a result, you can imagine when I answer how does it work, depending on your choice of like where to run it, how to run it, you have different paths to go. But this is a simplified way of thinking about it. So you need an analytical model if you want to run a study based on the question that you have. You can use our CAD plugins to build it, or you can just write your own to generate those models. Then you have to select a recipe that you want to run. Again, you can develop a new one if the one that you want doesn't exist. You can run the recipe, and in this case, you can run it locally or you can run it on Pollination. It's your choice. And finally, you can visualize the results. Similarly, you can do it locally using CAD plugins or the API, use it in any other platform that you have. If you want, I'm not going to talk about all those stuff. This presentation is about the workflow, getting the stuff out of what we call BIM, which really, in this case, is like Revit. We have plugin for Revit for now. But that's the one that most people use. And yes, we're working on the IFC part, like for people who will ask about it. Like we have a proof of concept for IFC, mostly for daylight modeling. But I did a presentation at a Speckle Connect and like talked about this stuff in length for an hour if you want to watch. And now it's available on, oh, OK, we're going to watch this for an hour. And now it's available on YouTube. Wouldn't that be great? So product updates. Rhino plugin. Let's start with the Rhino plugin. So for the Rhino plugin now, we added color by, new color by functionality. So now you can color by model by all the model properties, and you can do by face type properties. So your room properties and face type properties. This is helpful for QA/QC. There is another slide that you will see how it works. But this is if you have been using Ladybug tools. This is very like you should already know about this and like how it works. Then we added a new rebuild solid. Check this too. So you have all these models that you get. We already had the 2D workflows to fix the model for you. Now, if you get a model that's not necessarily aligned closely, you have this command, and this command automatically fixes it for you. It doesn't work for very complicated geometry, and we didn't decide to do that. It's just like 90% of the models that we get for really energy daylight modeling are simple. You know, like we have functionalities, Rhino, you can do whatever you want for complicated geometry, but as you know, like our focus in on real world problems. And real world problems, we think this is going to address a lot of the cases. We added 2 new commands for upload and download the models, which I'll show closer to the end, like how we use it, or have a slides for it. I'm not going to show it live. But now, if you want to share models with other people, you can basically, or you want to keep working from different machines, you can basically say PO upload model. It allows you to log in and upload your model to Pollination. And then there is another one, PO download model, that you can download that model from inside Rhino. And then you get 3 different options for opening the model, syncing the model, and importing the model. And the most interesting one is the sync model option. So open model is just creates a new model. Import model adds it to your existing model. Sync model is the one that gives you the option to say, it's a starting point of some sort of, you know, get kind of workflow. It's not there yet at all, but we're starting to get there. In a way, now you can see there is a base model, and we are syncing with another model. You can see there are 4 rooms that has been all these plenums. Actually, there are 5. 5 plenums have been added here. These ones are updated. And one thing that's very important is you can make a decision if you want to only sync geometry or only sync metadata. Again, I'll show why is it important, because of depending where you in design process you are and who is taking care of model, like how the model comes back and forth. Sometimes you only want to sync geometry, sometimes you only want to sync metadata, and someone you want to use both of them. This is one of those that will take a lot of work to be what we want it to be. But this is a proof of concept. We love you to test it and give us feedback what you think about it. Is it like really helpful in your workflows? So the improvements that we have done, room manager, sort by and filter by, they had like a small box that we have fixed. Solve adjacency, last time we tried to make it faster. As a result, it wasn't as stable. Now it should be stable. You can try the large models. We have tried it with models with hundreds and thousands of zones, and it works. And you probably know Minbo has this thing, like my computer crashes always. Like I designed my computer to crash. Even on mine, it doesn't crash, so it shouldn't crash on your. Like I'm presenting the worst case scenario apparently here. And then one of the other things is for all the other commands that we had for you to go to 2D and come back to 3D, now we keep the data. So you don't lose the data. If you have a 3D model, you want to fix it in 2D, you change 2D plans, extract 2D plans and fix it and go back to 3D. You keep your data. This also will be improved. This is kind of like right now we go from Honeybee JSON to Rhino geometry. Ideally, we want to go from Honeybee JSON to DF JSON and then come back, so we keep all the or most of the data as much as possible. So the development roadmap for the Rhino plugin, we will fix reported bugs. Like if you find bugs and report it, we're going to keep to fixing it. We have a list of improving reliability and stability. As you know, there will be always crashes, but they're like we are minimizing them, and like hopefully we will get them to 0 for normal workflows. We are doing the feature freeze now, from now closer to the end of the year. So the plan is to go from WIP to beta and then start making a Rhino plugin paid. It has been, I don't know how many months we have been working on this, but it's in a very good place to move on, and we're very happy about that. Well, we will communicate the overall process as we do, so don't worry about that. It's not going to be like one day you can't use it anymore. For Pollination Revit plugin, we fixed several bugs. Thank you for everyone who shared their models. They're really helpful. I mean, we have a backlog of models that we're testing, but if you still have a model that you want us to test, share it with us. It might take longer than it used to take, but we're still going through every single model, and every single of them usually helps, which is kind of both great and sad to see like how people use. There is no standard way of doing things apparently in the industry, how you model your building. Even for visualization and documentation, I don't expect people to do Revit models for environmental building design or building performance simulation. We fixed overwriting bug in df.json export. If you use df.json for the height, it would be overwritten by the UI. We added support for Revit design options now. So if you have different design options, now you can load the primary one, and you can go through them. Before, like, it would just consider you don't have design options. And then we fixed the bugs for models with no curtain walls. That was also an interesting one that we just assumed every model has a curtain wall. What do you mean? Until we got one that it didn't, and then like, oh, the thing doesn't work. So that was like, they're all like a smaller bugs that we fixed. And we improved shading parsing. So for complicated shading geometries that you have now, we can parse them as clean geometry. A new feature that we added is daylight we call df.json export with detailed apertures. So one of the things that we have seen, and I'll talk about it more in the rest of the presentation, is people get Revit models that are so bad that they just don't dare to clean. They're like, this is not something I want to clean. But at that point, what you can do, you can actually get the curve, get an extruded curve, and get all the apertures. Because the thing that takes a lot of time to export and clean from a Revit model to like a single face that you want to use for this environmental studies is aperture. So with this workflow, you can quickly get a model which is like 80% there, and then bring it to Rhino and use our 2D workflows or 3D workflows to quickly fix the stuff that you want, and you don't have to redo the apertures. That already like saves a lot of time. There is an upcoming feature, we call it Room Manager, and we are starting with so the idea of Room Manager overall is to try to help you fix the rooms, because that has been the thing. We export rooms and people are like, we don't want to fix rooms. We don't get models with good rooms. So how can you populate rooms? How can you remove all the rooms that are not placed? And this one is like how you can adjust the height of all the rooms in different levels to a place that you don't have to do it one by one manually. This one, as I said, like right now it's only for room height, but we will add more features to help you clean your model in Revit sooner. Yep, that's the part that it will be added. It will be added up there. It's called Room Manager, and naming hopefully Room Manager tells you what it does. For Pollination Platform, you probably have seen already under settings, your account usage from last month. We introduced this feature, but it used to show the data only from the time that we deployed the feature. So now we went back, and now if you see the values is real value usage that you have done. This will be helpful when you want to go to a paid plan to understand, like to get an idea about like what is the amount of usage that you have. Does Room Manager change the properties of the room in Revit or just in the HB.json? So the Room Manager fixes stuff in Revit. There are two of them. Good question. Thank you, Justin. So Room Manager and export model are the two different things. Room Manager is for getting the stuff fixed in Revit. So it's reusable, so you don't have to do it every time on HB.json. Export model is the one that takes those and makes HB.json out of it, or df.json or GBXML based on what you want to export. And something that I said like we're going to show today. So for the last month, we have been working on this concept of Pollination Apps. And this is not a new idea. This is a presentation from 2020. If you have seen this, we always had this roadmap, if you want to call it that. OK, run simulation faster, cloud computing, that's done. Recipes, like reusable units of logic, that's done. But we wanted to have a lens for you to make sense of data and an app to bring them all together and be able to share with people. And we did different like ways of doing this. We tried even a couple of technologies. We built some prototypes, and none of them really felt right until we realized that for people actually doing this part of like building something, looking to the results, and presenting it, they're all together part of the same experience. And this is something that we should have known because of success of projects like notebooks, right? Jupyter Notebook, like all the other notebooks like Observable for data visualization. So we should have known this already, but it took us a very long time. It took me a very long time. But good news is we finally have a solution that we think it's very close to what we want it to be. So introducing Pollination Apps, customized interactive applications powered by Pollination. But we didn't develop our technology from scratch. So what we did, Pollination already exists. There is another project called the Streamlit. If you haven't seen the project, it's called go to streamlit.io after this presentation and check it out. It's great work that has been done with a very similar idea. So we want to make building simulation easy. I mean, easy, more like accessible, easy for people who care, not easy for everyone necessarily. And a Streamlit is a project that make building data apps easy. So they have abstracted a way to write like a couple of lines of Python, and then you have you have an app, basically a web app that you can deploy in all those. So what if we bring these two together? Then that will make building simulation apps easy, which is what we wanted to do all the time. So this is an example, and I can show it live too, or let me show it live. So this, I'm going to show you a couple of apps. And the key is this app is only hundreds of lines, like the whole thing to write. And because we are running it on not really reliable server right now for testing, it goes, I need to reload it, but this is the whole thing, that the way it works. So this one is specifically designed for a recipe that runs lead. After you run lead, and you can see it's made by Streamlit. There's a default URL here that you can use. But then once you run a lead simulation, it comes here. We have our 3D viewer, so we basically made a component that you can use it directly in Streamlit. You have all the results that comes with this simulation. In this case, if you know lead, and this is option 2, the data that you get are pass-fail is the illuminance for 3 p.m., illuminance for 9 a.m., and pass-fail for 3 p.m. and 9 a.m. If you want, you can go and see like every single of this result, and we put the default value. Sometimes that makes sense and sometimes not. So this is something that you can explore. More importantly, you can get like a breakdown. And actually, if you get more than 3 points, there is a moment of celebration. I'll do this again. Here's a good feeling. So in this case, because you get 3 lead points, lead credits, it shows that there are like information about how to use this app. And there is also information here for space-by-space breakdown. You can imagine there will be a like download PDF, all those. The important thing is you can build this app, you can edit it, and it's all in Python and scripting. We realized recipes are really hard for a typical user to edit. So that's why we're very excited about the apps. And it doesn't need to be like this, right? This is another app that we wrote. And let me load all these apps while I'm talking. So this one is for side-by-side comparison of the result for daylight factor studies. And all of this works with certain recipes. So you can imagine in the near future, when you run something inside Pollination Web, it says all these apps are available for this recipe. So you can get like hundreds of apps that people have developed that works with that recipe. In this case, it's like 22 different daylight factor simulations that we have run. And it's the first time that you load it, it downloads all the results from Pollination. And now you can see, like, I have an option here of like how many options you want to compare side by side. I can go to 3. And the rest are like normal stuff, right? You can just go here and select from the options that you have. You can have a metric, an additional metric. I just here calculate the average daylight factor and percentage area that's larger than threshold. And you can play with threshold. So this is 2%. I can make it like 7%. I don't know where the standard goes, 7%. But you see the app gets updated live. And the one that people have been asking forever, with like 200 lines of code, now you can build something very similar to Design Explorer that we had. So this is Facebook's HiPlot, which is another type of power coordinate. It has the functionalities of power coordinate. If you know Design Explorer, you already know this. And I know people are thinking, OK, this is good, but where is my geometry? So here's your geometry. If I click here, again, all these options will be loaded from Pollination. It's connected to your run that you have done. Again, I don't copy new runs here. I use the default, but you can copy a new one and it will load those. And then, yeah, I can do all the things of saying, like, the one that has the highest level of daylight factor and then uses the minimum number of shades. What are the options that they have? So by now, I think like everyone is familiar with this kind of workflows if you have worked with Design Explorer. So that was good, but here's the thing. Are we building only web apps now? So what happened to the CAD plugins? The good news is that actually your web apps can also be CAD apps. You know, we have this thing of like, write it once, use it everywhere for our recipes. So why not for apps? This is the same recipe, the same app that I showed you for lead visualization, with the difference that we're loading it from inside Rhino. And the difference is when you load it from inside Rhino, we have a small functionality that allows you to add functionality that speaks directly with Rhino. So I just can send that model from that web app that I just wrote once, and then directly send my model to Rhino, or from Rhino send data back to the app. I don't know, like, I hope that's clear. But that basically means you just write an app once, and you use it on the web, and you use it locally. So this is, I don't know why I press escape, but this is another one. A lot of people ask for like weather data visualization. We have been discussing like what's the best way of doing it. And now I think we know what's the best way of doing it. You just like develop an app, put all the time and energy there to get it right, and then make it connected to Rhino so people can use the same web app to work directly inside Rhino. And in theory, the same technology should work in Revit. We haven't tested it. So what are our plans for rolling this out? Oh, first I have to talk about this, actually. This is, again, like another thing that we have shown before, right? Like, we think this is the way our industry develops stuff. This is how we want it to be. We want us to build together on top of a good infrastructure. And when you do it like this, all this part is reusable, means you can go faster and you can go further. And to put it like the way we have developed the stuff, there are engines in the bottom, then you have libraries, then you have the APIs, then you have plugins. Before, we were thinking recipes are here, but recipes are going down to plugins and takes longer. So the difference is it takes years, ages to write those engines and then libraries. For an API, it takes months of work to provide you an API. But then when you have that, in days, you can write plugins for Pollination. And now with apps, in hours, you can have something production ready. And I think that's the whole magic, because it's built on top of this infrastructure. And again, we are not the only one doing this. You know, like even in our industry, I like encourage everyone to check what Hyper is trying to do. They're trying to do it in a very larger scale, but it's a very similar concept, and I really appreciate what they're trying to do. Observable, you have Kaggle. I had the slide for that I forgot to put there. But then GitHub is also another option that you have. Like, this is possible. We can work together to build better solutions instead of building everything from scratch. So the way it will go on, we will release Pollination Streamlit on PyPI. We have actually released an alpha version which calls Streamlit Pollination. If you want to try it today, that's also available. We will put a handful number of samples that I just showed you. We'll just open them so you can see them. There's a little bit of work to be done on the core library to make it easier for a typical Python developer to be able to develop. And then we're going to listen to you, and we help you to develop your apps if you want to develop any apps. And already a handful of people started to do the apps because we showed these apps during the AEC Tech workshop. And then during the AEC Tech hackathon, we saw, oh, some people started building apps, which was great. Great experience. OK, this is the first part of the presentation. I can take some questions until we go to the BIM to BPM. Any questions? Thank you for the interest. Any other questions? OK, if there is no question, let's go to this topic that is very close to my heart, and I think a lot of you on this call. How do you get stuff out of BIM model in a useful way for building performance modeling? And how do you do it for imperfect models and imperfect world? So this is the ideal workflow, right? Like, this is the one this is our slide. And there are a lot of marketing slides like this. It's like, oh, you just have this model, click. Isn't this amazing? Everything is clean. Just run it, go. And honestly, for this model, it actually works. But this is because this is this model, and we have worked on it, and we cleaned it. And like all the other things that you see, that's how it works. But in real world scenario, when you talk to people, these are the things. So there are cases that people don't have a BIM model. They don't even have 3D models. They only have 2D. They don't even have CAD drawings. They have PDFs. So that's what happens in the real world. Then we have models that basically they have no information, like models with no rules, no nothing. Or there are models that have too much information. Like we have the ones that has, like we got a model this week, like a couple of days ago. It had tiled and tiled with just like Revit couldn't resolve the rooms with tiles and all those stuff. Then you have model with wrong information. That's the worst case scenario. You have a model, you're really happy, but then it includes wrong information in it. So if you want to automate the whole process, it basically, instead of helping you, it's just like you're getting wrong stuff out of it without being able to check. The other thing that we see is like you have the model is clean, everything is ready. You don't dare to touch it because there are like so many stakeholders on the same model. And people are like, I just want to get out of this model and do my stuff outside instead of just like fixing this model inside because I can't touch anything. So many owners are using the same model. I can go a long list of like why I think that approach of like single click is not going to work. And I want to make an argument here that there is no single analytical model. I think because Revit has this concept of analytical model and people like, we all talking about analytical model as just like, and we mean different things when we talk about analytical model. I think there is no single design model too. Like at least all the projects that I've worked on, there are several versions, iteration of the same model that are designed for doing different things. And if you think about that, then you have to ask key questions that before extracting that model and before talking about the analytical model. One is like, what is the quality of the input model that you have, right? The other one is, what are the key questions that need to be answered? Why do you need this analytical model? Is it energy modeling? Is it daylight? Do you only want to get loads? Is it like radiation study? You don't really need an analytical model for that. And a lot of people apparently don't know that. The other thing is, what's the desired type of simulation that I just talked about? What are the possibilities of redoing with the work with the same model? We have projects that people come with a model and say, this is not going to change, this is built. We just want to extract it to run some sort of a specific studies. I think that's a very valid choice and like a valid argument to extract the model. And the way you approach that model is going to be very different than a model that you just do it once and in a week you have to do the things again. And then the question about who are the end users? Are you the user of the same model that you're extracting or you're modeling it for someone else? Of course, you can be way more forgiving if it's you because you know it, right? Like how the things happen, and then who owns the BIM model as I talk. Because depending on who own it, you may have different type of solutions. All of that is, I said that because the pollination way is designed based on these questions, right? The way we have developed it is one is the pollination way is to develop a cohesive toolkit to support different scenarios. We don't think there is a single tool, there is a single click solution. We have a single click solution, and we say that. Provide utilities to identify issues in the model. So the other thing that I think is people don't spend enough time on, and software developers just leave to users. It's just like, we just export the model, you just fix it in your software. So no, like you have to provide all the utilities to help people fix those issues. Then identify the issues first, and then fix the issues. But they're both important. Sometimes just showing people what's wrong is like 90% of the solution because they can fix it sooner than any automation that you can write. Then decouple geometry from metadata for support flexible workflow. This is something that we have learned the hard way, and I think like we are in a good position. And I showed you in the sync command. So we keep, they're loosely connected, geometry and metadata. And because of that, you can just update geometry and keep the metadata, or you can update metadata and keep the geometry, which helps you not redoing the stuff. And then provide validation routines. Without validation, the whole thing that I talked about will end up being like, the file formats for interoperability has been around for a very long time. It's not like the idea that we came up with. But I think the problem has been that we didn't have the right validation routines. So like the model go from 1 to 2, 2 to 3, and then when you compare 1 to 3, there are like 2 different models doing different things. And of course, at the end is the solution should always be customizable by user, and there should be ways to automate that workflow. So if there is something that you do over and over, you should be able to automate it without talking to us. I think that's the key. With that, I'll just go through a couple of the slides, or a few slides quickly. So cohesive toolkit instead of disconnect or centralized tools. We written this with Chris years ago about tools versus toolkit. So we don't think disconnected tools is the solution. We also don't think centralized tool is the solution. We think it's a cohesive toolkit that data goes between different platforms is the final solution. And we support solutions like this, which we think people use a lot. You can run stuff in Pollination, Rhino, Energy, Daylight, Simulation, Comfort. You can run it in Pollination, but we think it's totally fine if you go out and go to other software. And hopefully we will have a better alternative than GBXML at some point, or a better GBXML at some point. And to do all of that, we developed our own schema, HPJSON. And the reason we did it, it has validator. It only has 5 geometry rules. So if you're a software developer, you don't need to know how geometry rules are in Energy Plus versus Radiance versus like Butterfly for CFD for OpenFlow. You don't have to know that. That's our job. Like if you just only 5 geometry rules that we have, which are very simple, the rest is taken care of in our translators. It's developed for multi-engine schemas from day one. And it's a scriptable. So you can automate the stuff. You don't have to write your own script from scratch to do that. And this is how it works, kind of like to give you an idea. So HPJSON is in the center. And then we have CAD tools writing to HPJSON. We have from HPJSON going to all the simulation tools. And we have connection from HPJSON to other formats like VTK, which we use for 3D visualization. That's the one that I showed in the apps. Like you have the 3D model because we use VTK library. And as a result of that, you can do things like this too, right? If you want to stay in the same platform and export a lot of different formats, you can do that too. You can go between the tools, or you can work centrally in a single tool and have a lot of options. Building validation. Again, we have a validation command, and we have implemented it to all our CAD interfaces too, to make sure you can validate your model. And when you hand off model, you know it's a validated model that you get. This goes back to the thing that I said, there is no single analytical model. So we support different level of abstraction. The first one is what we call Dragonfly model, which we initially designed for urban studies, but now we found it very useful for load calculation, basically simulations that you don't need a detailed geometry. Mostly you want to get the area base and volume of the model. When the model is not clean, this is usually works the greatest because you have the lines, right? And it extrudes up. It adds all the aperture, calculates the area, puts it on the window. The new one is the DFJSON with detailed windows. I just talked about it, why this is important. This is when you want to do the same, but you still care about where the windows are. You want to do daylight studies, you want to do comfort simulation, but the model is not clean. And then you have this, that if you clean up your model in Revit, we can get you like 90% where the model is. I mean, 100% for daylighting, if you want to run daylighting. For energy simulation, there are still things that you have to do to make it totally workable. The other thing is we support partial model export. I spent years of my life arguing this with people to make it available, never happened. This is just this idea of like you need the whole model at any stage of design is obnoxious. Like, so now you don't have to do that. You can just take the part that you need to do the study, do the study, come back. Yeah, freedom and flexibility here for you. Then we wrote a lot of utilities to identify and fix the issues. So when you get the 3D model out, most of them are implemented in our Rhino plugin. This is an example that probably you have seen that gives you access to like where the zones are not next to each other in 3D, so you can quickly fix them. Before, we didn't have a 3D way of fixing it. I just showed, like now we have this rebuild solids that does that in 3D model for you too, so you can quickly fix it. We have the same functionalities in 2D. We have seen a lot of people do this work of bringing the model in, drawing all on the line, and then end up with this. And you don't notice until you extrude your geometries and you do intersection, and you end up with cases like they're very close that you don't even see. And now you can see cases like this, and you can identify those quickly, and we have a command for you even to fix it automatically for that one. We also have this command that like shows the lines that are not necessarily horizontal or vertical and automatically fixes those. And these are like, I'm talking days of work for cleaning up these models, now happening in minutes. Yeah, this is the automated one that I just said. You can run the command, and you can see how the original line has been moved, and everything is just now clean. Then we support this 2D to 3D workflow and coming back. We showed that, but I didn't know if everyone was here last time. But you get these 3D models that comes, and then people don't know 3D as well, especially when it goes to energy modeling side. They're not used to working in 3D models. They're much better doing things in 2D. So we thought how we can do that without losing data, because otherwise, if you do do this and project and like make 2D, you lose all the data. But what we do now, I just created a 2D, made the edit, and then I'm going to extrude them back using PO extrude. And what it does, it keeps all the layers the same, and it knows what used to be the height of the building. It doesn't work if you have complicated geometry, but again, a lot of models that we have seen, you're not really having any complicated geometries. Most of the models are just simple extruded blocks that we have to clean, and this is going to save you hours of redrawing and managing layers. One of my least favorite things to do. Then finally, if everything works well, and I will answer the questions, I see them. If everything goes well and you get at some point to be in agreement and make the culture and everyone builds the Revit models in a good way and you have a project that you can really work together, we have workflows that can help you a lot. One is this match properties command. So similar to how you do match properties in 3D modeling, now you can do match properties in energy and daylighting and comfort modeling. You can just set one and then match properties quickly and apply it to the rest of your model. The other thing is this. So far, when you have a design track and analysis track, they go out of sync. And usually there's no way to put it back. The chart that I showed initially, right? You have a design model, you get original optical model, you send it to your consulting person, and consulting.add construction, add HVAC, add programs, and then you have a new design illustration. And usually in normal, right now, the way we work, at this point, this model is not that useful anymore, because you, depending on how much this has changed, you have to redo stuff, right? But now, what if you could bring the geometry and sync the geometry here without losing all the work that you have done before to set up all the analytical data? And then you add HVAC, there is a newer version, and this time you send it back, and they are going to sync the metadata with that geometry. I'll show you like 2 workflow on that. Hopefully that makes more sense. So this one starts with a model that has no program, right? This is just geometry. And then I have another model that programs are set. I'm bringing that model in with sync command. It checks to make sure the model is valid. And there are extra plenums that I want to use. And all these rooms has been updated. I don't want to get any of the geometry change because I am the owner of geometry. I just want all the metadata that has been added. And bingo, now I have a model that has my geometry, but the metadata that has been set for that room. Then this is a different one that goes backwards. So this one is an analytical model that you're working in, and the design model changes in Revit, right? People have Revit, and they send you a new HV-JSON. What do you do at that point? So what you can do, again, you can bring it in, and at this point, it tells you which room has been added and which room has been updated. So I'm just merging both, and you can see now I have 2 new rooms. Again, this model is a very simple model, but you can imagine for larger models how much time this is going to save you. And as I said, this UI is going to change and be much better. And if you do software development, you know, like we have learned a lot of things from how Get works and how software basically send a pull request, you merge it in, you solve conflicts and all those stuff. Finally, as I said, all these things are great, but we know this is the reality. And I took this from this, I modified it from this great Why Figma Wins post, that there are features here and times here, right? By the time we are early on now, we're just doing quickly, we add features when you ask for something. But at some point, we can't do it as fast, because anything that goes to the core product needs to go through this thing of like, how many people are using it? Can we like keep this thing and maintain it long term? All this stuff, right? And that's not something that you want to wait for, because your needs are going to grow like this. You will ask for more and more, and I need to do this, and I need to do that. And this is the gap that can be resolved by custom scripts and plugins. that's kind of like why we're really obsessed of whatever we do, you should be able to build on top of that. There should be a SDK, there should be an API, there should be some way for you to automate. And thanks to the CAD platforms that we are developing with, inside Rhino, you can use a Python script to edit all this stuff. We have sample code already on GitHub that you can start. This is another example of one of the things that you have to do over and over is adding plenums to your model when they come from Revit. And you can just do it as simple as this. Like, if this script is probably like less than 100 lines of code, and most of them is for the UI. Done. It basically, I pick the level, then I extrude the roofs, just name them. I didn't have to, but just to be clean. OK, and here you go. So now your plenum resolved. You can do this in Revit, but yeah, go read. Like, there are articles about how to do that, which is very interesting. Next, oh, this is another one that it's not only about creating new geometry thanks to Rhino and its powerful geometry kernel. You can do anything that you want. You can edit geometry. You can. This is like window to R ratio, which is again a very typical workflow that people use in their workflows, which is now automated. And again, this script, similar to the other one, is already available. You can go and use it today if you want. And we are working with McNeil on to make sure like we add support for Rhino inside. People have been asking for it. It is possible. We had a call with them, and as usual, they're really supportive. OK. You can get started here at pollination.cloud if you don't have an account or if you haven't checked it. And you can get involved at pollination.community, which is our Discourse platform that is already pretty active, and people ask questions and help. I can go through the questions on the like message box. I think is that the right way of doing it, Janki? Or
yeah, we have about 10 minutes left, so I would definitely answer the questions.
OK, sure.
They're from Justin and
OK.
Chang, Demi Chang.
OK, so let me start from the top. Justin, I answered that. Demi, by area-based model doesn't mean the floor area is accurate while the actual geometry of the floor might not be. Yes, that's correct. The floor area is accurate, and we do a good estimation of the volume. So the overall volume should be close to the volume that you have inside the Revit model, or your room has inside the Revit model. But
and she has a follow-up question for how do you deal with the wall thickness in that case?
Revit does. Revit does. So when you export the rooms, you can select where you want the room line to be drawn. We just take the center for the interior walls and take the outside for the exterior wall. But that's something that you can change, and we can actually expose that to change. Okay. Do you want to? How do you?
So the other question from Justin is, how do you run the different levels of abstraction in the Revit plugin using an existing model?
Abstraction. So when you export the model, I open Revit while I answer other questions that you have. When you export, there is an option that if you want to export with HVJSON, DFJSON, and then DFJSON, you have two different options. There is another question of where to find this automation scripts. If you go to GitHub Pollination, search for scripts. So this is the place. The ones that I used were actually inside edit and report. I copy them here. And the other place that you can go, if you go to our, what is the name of it? User manual, we actually have a link to all this. So that was that question. The Revit question, and I can answer it here. What is the?
And then go ahead. The other question Justin had was about extrude 2D. When you do that, does it keep the window information?
Yes, that's the thing that I said. Right now it doesn't, but if when we implement DFJSON, it does. If that makes sense, because DFJSON is a 2D representation that keeps all the aperture information. And now with the detail that we have, we can totally do that. Right now, unfortunately, like the 2D, it doesn't, but it's very doable. And that's a great question. So answering about different level of abstraction, when you come here, HVJSON is the full-fledged model. that tries to extrude the 3D geometry as correctly as possible. Then you have df.json, and there are two options here. Detailed is the one that keeps all the aperture, and simple ratio is the one that I just showed that just does the overall area for you. Depending on how clean is your model and what level of data you want to chip, we can basically pick between this. Did I answer your question? I hope I did. Any other questions?
No, I think that was the last question.
Quick question. So when should we use HBJSON versus DF.json?
Well, if your model is fully extruded and you don't want to fix the rooms inside Revit, then that's when you can use df.json. If you have the time to fix the stuff inside Revit and the model is something that you want to reuse over and over, it's better to talk to the model owner and use this room manager to fix the stuff inside Revit, so you can use HBJSON. That will decrease the time for post-processing inside Rhino or other software that you use for simulation. That's how I make the decision, because in df.json you're going to lose some level of geometry information. If it's the whole model is extruded, df.json with detailed will be the same as HBJSON. Is that correct, Chris?
Sorry, just well, the question was.
I said, like, if the whole model is only extruded, df.json with detailed window is the same as HBJSON.
Yes. Yeah. Right. Exactly. Yeah.
So IFC to HBJSON translator will be nice to have. We are working on it. If Devang is on the call, I think he can actually share a run on Pollination that already is using an IFC model that we use for daylight simulation, and the model went through quick, very clean.
Yeah, I can share that model.
If you just, because we have 6 minutes, if you just send it.
I'll just
here,
share the link here. Yeah.
Yep, and everyone can check it out. Or maybe I can also open it up so people can
Yeah.
see. Yes, we are working on that, but IFC. How can I start using a stream-related pollination and ladybug tools? So you want to start now, or can you start tomorrow? The answer is different. If you want to start now and you don't need a lot of sample code, if you go to Pollination community, there is a discussion here, this one, Colab and Pollination, that you can see the alpha version of the library that I just talked about. Where is it, actually? She shared it somewhere here. It's a streamlit pollination. You can use it. There is no sample code there, but you can start here. And as you can see, I already assigned this to myself to make the better version of the library available and make the sample files available, so you don't have to start from scratch. So if you give us a little bit of time, early next week, I think is the safe time to tell you will get something for real. And I love to see this, that you really want to get it started now. That's what I was hoping to see. Right. So this is the IFC model that we just talked about. So this is the model exported from IFC that Devang just shared. Maybe give me a time to just show like how cool this 3D viewer is. So now you can see all the results here. And this is annual daylight, so 0 to 100. And let's go for useful daylight illuminance. Okay, any other questions while I'm
Yeah, there is
some
one more
visualization?
question. Yeah, from Ian. It was actually in the QA section, which I didn't know they have, so kind of nice. He's asking, does HBJSON have a JSON schema?
Oh, yeah.
Yeah.
So if you go to GitHub, Ladybug Tools.
Sorry for putting that in the QA. I have no idea how to use this.
Oh, it's Ian Q. Hi, Ian. I didn't know who.
I was tough. Huh?
There are so many Ians. Like, I don't know which Ian is this Ian. So this Ian is here, you can get, if you go here, actually, the model schema is all documented. You can download the Open API stuff. I think you know all these things. I'm not going to
Yeah.
for you. So yeah, so just look.
That's fantastic to know, because obviously
you.
we can use the JSON schema to auto-generate, code libraries for Hypar, for instance, because I really want to make an integration with Pollination. We just have to find the time and the manpower.
Yeah, exactly. Likewise. And I'm good that I gave you a shout out here then.
I
Here's
know
the-
that was
the
very
Hypar guy.
very sweet and uncalled for, and I don't think we're trying to do anything on a larger scale than you guys are. I mean, I think the apps are wonderful. It's a great idea.
Thank you so much. Yes, this is here, and you already probably know we have SDKs already for Python and C# so you can just start using those.
Yeah, we could probably use those just straight up.
Yeah,
Okay, great.
just right
Thank you
away.
very much.
Yeah, no worries. Awesome. Any other questions?
No, I think that's it. We're also at time, so thank you everyone for joining us, and we hope you'll join us again next month with a theme to be announced.
Right. Hopefully apps. I hope.
Yeah,
Unless someone
hopefully
else
apps.
takes over and wants to do something else.
You know what's going to happen? Justin's going to create a Streamlit app, and he's going to join us to show what he did.
Yeah, I think we want to brand it as Pollination Apps powered by Streamlit, but we'll figure that
Yeah.
out. They are Streamlit apps powered by Pollination. Okay, great. Thank you so
All right,
much. Great to
thanks,
see you
everyone.
all, and we'll see you next month. And happy Thanksgiving for people in the US. Take care.